Hello, I'm Patricia Churchland. I am at the University of California in San Diego. I am an Emerita professor. I work at the interface of neuroscience on the one hand and philosophy on the other. People have wondered for a long time whether what we experience through touch, through smell, whether those things are really properties of the physical brain or whether they might actually belong to a non-physical soul. And Descartes, of course, famously said they must belong to a non-physical soul. And since Descartes' own argument was not terribly convincing, philosophers have tried to explore that question, not really using data so much as using particular arguments. And one argument that got a lot of play in the last century was what's known as Frank Jackson's Mary argument. Suppose that Mary is a scientist who knows all the information there is to know about the brain. She's very lucky in that regard. She knows all the physical information there is to know about the brain, including all about color vision. However, Mary has been sequestered in a room that is entirely black and white, and consequently, she has never been exposed to any color. So the question is this: will Mary learn something when she emerges from her room into the wider world beyond? And everyone seems to agree, yes, she will learn something. And now comes the conclusion. So while she's in the room, Mary does not know something about seeing green, namely what green looks like. And the conclusion that Frank Jackson and many others wish to draw from that is that color experience, therefore, cannot be a state of the physical brain. In other words, physicalism, according to which all properties of our experience, our knowledge, our capacity to move, all properties are subject to physical rules, physical laws. So the first premise, namely that Mary knows everything there is to know about the physical properties of seeing green, actually begs the question against the physicalist. And to see why that's true, we're going to go a little bit further. Now, here, of course, is a depiction of the human brain, the physical human brain. And what we know is that there are many different pathways to knowledge, that some of them involve language and the prefrontal cortex, but many of them do not. Many of the pathways involve sensory systems, and they are not language mediated at all. So let me be a little bit more specific about that. Mary in her black and white room lacks knowledge that's accessible only via very specific pathways, namely the visual pathways to color, and that's in the dorsal stream involving region V4. Very simplistically put, the signals go from the eyeball, from the retina, to an area in the thalamus, then to V1. And at V1, they split into what's called the dorsal pathway, which goes up here, and the ventral pathway. And color signals are diverted to the ventral pathway. And you have to have this particular region, namely V4, in order to see color. And we know that, for example, from lesion studies as well as from stimulation studies and in other ways. So we know that V4 is essential. So one of the things you want to ask about poor old Mary in her black and white room is whether there will ever be any stimulation of the ventral pathway, at least that part of the ventral pathway that involves V4. And it presumably is never stimulated. Now, just to remind you then, the frontal cortex is these frontal bits. And many of what we think of as the more sophisticated or complicated functions of physical brains require the prefrontal cortex. But apparently, one can have great losses of prefrontal cortex, losses of function of language somewhere in here, for example. You can have those kinds of losses and still be able to see colors. The prefrontal cortex, this is highly oversimplified, of course, but just to give you the flavor of the kinds of functions that the prefrontal cortex is responsible for, are not simple perceptions of motion or shape or color, but they involve, as we think of it but don't understand well, higher cognitive functions. One of the things that you want to ask is, realistically, would Mary have normal color vision upon leaving her room? And because we have to assume that since Mary has learned all this neuroscience over many decades, that her brain has long ceased to be in the developmental stage. And what we know is that in all stages of early development, the appropriate kind of stimulus is really important for setting up the appropriate kind of wiring. And most recently, this has been demonstrated by some really remarkable studies on children who were born blind, but who subsequently underwent surgery that allowed them to see. So the surgery and the work has been done by Panwa Sinha at MIT, and the children involved are children in the very poor areas in India. Why is it that they are congenitally blind? And the answer really depends on vitamin A. If the pregnant mother does not have sufficient vitamin A during her pregnancy, then what happens in the eyeball is these very thick cataracts develop, or sometimes corneal tears develop, so that when the infant is born, it is unable to develop the capacity to see. When Sinha realized that this was essentially owed to cataracts, and since we know that cataracts can be removed and replaced by artificial lenses that are actually very efficient, he began to do that in very large numbers of children in India. So one of the things that we maybe didn't used to be able to answer was whether Mary would have normal color vision upon leaving her room. And the answer is essentially she would not. Now, one of the things that was very clear about these children after about 48 hours, when their swelling in their eye had had a chance to diminish, one of the things that people did notice was that they were really not able to identify objects at all. They didn't see colors at all. Some of them eventually, if they were still quite young, were able to go on to develop the capacity to see colors in a sort of a way, but nothing like the way a normal seeing child who developed normally would be able to see colors. And one particular difficulty that I think is worth mentioning is that it seems to us so obvious that if you see, say, one hand on top of another hand, that one is behind, you could tell where one hand is and what part is blocked. But these children who were congenitally blind, it took them quite a while, like months, before they were able to discriminate objects where one, to some degree, maybe small degree, overlapped another. What was found, which I think is really quite interesting, was that as long as the children had really quite good motion capacity, they were able to acquire a capacity to identify objects and see that all of the lines and shapes and so forth went with this, and a different set of lines and shapes went with that. But in general, the capacity for color vision was not terribly good. Those of us who have been privileged to have sight from birth see what's called the Ponzo illusion. Now, on the left-hand side, you can see there is a red line there and a red line there. The red line here looks longer than the red line there. In actual fact, they are exactly the same size. And in the Mueller-Lyer illusion, which many of you will know about, the horizontal line is exactly the same length in top, middle, and bottom. And yet, of course, it looks much longer in this particular case. So one of the things that was observed in these children was that they were quite subject to the Ponzo illusion as well as to the Mueller-Lyer illusion. In 1688, Molyneux asked Locke an interesting question. Suppose that a congenitally blind person can identify a mug by touch. Now, if they gain sight, can they pick out that mug only using vision? And the answer is no, they cannot. They have to learn that sensory experience of touch and this visual experience of color and shape belong to one and the same thing. And it will not surprise you to know that this steam coming out of the hot mug is very, very puzzling to someone who just has regained their sight. Now, part of what I want to emphasize here is the importance of pathways and the importance of a developmental route in those pathways. One might say, and you'll see that this is a ridiculous argument that I'm about to give you, but one might say this. If Sally knows everything there is to know about pregnancy, and if Sally is, let us say, celibate, then as long as pregnancy is a physical process, then Sally, simply by virtue of knowing everything there is to know about pregnancy, Sally should get pregnant. Now, nobody's ever been taken in by that argument because there is very clear that the brain can know everything there is to know about pregnancy up to a point, but that to actually be pregnant requires a very different pathway. And the same is true in the case of color vision. If the pathways and V4 are never stimulated, then it would be ridiculous to expect that you will see green. Just as in the case of Sally, who knows everything there is to know, everything physical there is to know about pregnancy, of course, she is not going to get pregnant because the right pathways are not yet part of the story. So it takes about 3 months for a person who is congenitally blind. Now, Mary is not, but she is color deprived, which is rather like color blind. One of the things we know about people who are born congenitally blind is that the visual cortex begins to take over some of the functions of touch. So if you're reading Braille, that will be done in visual cortex. Now, I want to go on just to say a very simple thing about taste. Phenylthiocarbamide is a chemical that in Caucasians, about 25% find it gives a very bitter taste. 25% have no bitter taste. 50% have some somewhat bitter taste. Now, if I were Frank Jackson, I might say, see, what this tells us is that it's all about the non-physical soul taste. But it isn't. This is a genetic difference, so that depending on the receptor you have, there will be a genetic difference. and that will determine whether you taste it as bitter or not. Finally, I want to just say that there are environmental factors that determine how something tastes. There are biological factors that determine how things taste. And interestingly, we have begun to understand quite a bit about that. So when we think about Frank Jackson's argument and the physical brain, you want to say, look, if data on congenital blindness and taste are relevant, what on earth does Frank Jackson and his supporters think? What is the causal relation between the brain and spooky stuff and the consciousness stuff? And how do spooky theories mesh with genetics and with brain data? And what's so striking is that they have absolutely no answer and basically no interest. Thanks.